So we talked about last time how if we take enough samples for any sampling distribution, even for a mean, so even in this situation, if we would have taken enough samples from my class of 28, our sampling distribution will look normal like this. And that's going to allow us to make some pretty cool inferences about the population. So now that we know that this will happen, we have to formalize why will that happen. And there are conditions that we need to check to verify that our distribution is actually normal. And that is what you're seeing on page 507. Yeah. So these are the conditions that need to be met in order for your sampling distribution to look like this. So this graphic is just showing you that you have a population, you take a bunch of samples, you plot those samples. When you plot them, the mean or the center of your distribution will be the true value, and your standard deviation can be calculated using this formula. So we start with a population of size n and a given proportion p. We're going to take all random samples of size little n and compute the sample proportion. So this is our n with true p, or these are our samples. No, that's our population. These kids are our population. We take a sample of size n, we plot their p hat. It follows that your shape is normally distributed if you satisfy what is called the large counts condition. So it says it right there. This is called the large counts condition. What that is you have to calculate if your sample size times p is greater than or equal to 10, and your sample size times 1 minus p is greater than or equal to 10. So as long as this is true, and we'll do examples of this, as long as this is true, the shape of your distribution is normal. The center of your distribution is equal to the mean, and that means that the value of p hat, okay, so this looks weird, mu, and then subscript p hat is equal to the true p. So we check large counts to see, is it normally distributed? Then we check to see that the average sample value is equal to the true proportion. So this is just a fancy way of saying this. Your sample values are centered on the true value. How you get this is by taking random samples. If your samples are random, your center will always be equal to the true proportion. So here you have to do a calculation. Here you just have to verify that your samples were randomly taken. And then the last one is you can calculate the standard deviation or the actual spread of this distribution if you satisfy what is called the 10% condition. And all that means is that you are sampling at least 10% of the population. So that little inequality, n is less than or equal to less than or equal to 1/10 of the population. that's saying what I told you guys last time, that if once you hit 10% of your population, the spread is the same, no matter what your sample size is. So this is going to allow us to do some normal calculations, to calculate some probabilities. This leads us to determine that our sample is normally distributed with a center at the true value and a standard deviation that can be calculated. And that's all. This is just a summary of what's in those boxes. It's normal if you have large counts. It's unbiased if it's a random sample. And you can calculate the spread if the 10% condition is satisfied. You're hanging in? Okay, so let's look at how we would use this. Do you drink the cereal milk? A USA Today poll asked a random sample of 1,012 US adults what they do with the milk in the bowl after they have eaten the cereal. Let P hat be the proportion of people in the sample who drink the cereal milk. A spokesperson for the dairy industry claims that P is 70%. Suppose this claim is true. Okay, suppose this claim is true. What is the mean of the sampling distribution of P hat? So, mean. Where is that guy? That's this. So, did we take a random sample? Yes. A USA Today poll took a random sample of 1,012 US adults. So, we're going to say the mean of our sample is equal to true P, which is equal to 70%. How do I know true P? Because they say the claim is 70, suppose it's true. The claim is 70, suppose it's true. It says why? Because a random sample was taken. So we're assuming that the true P is 70%. 70% of people drink the cereal milk. How can we assume, or how do we know the average of our sample? Well, because the sample was random, we can assume it's equal to P of 70%. Okay, next up it says find the standard deviation. Check to see if the 10% condition is met. Okay, so we're going to say sigma. He's like the circle with like the straight line. It's like he's wearing a hat, but with no thingy do. Of P hat. Make sure that you write in that little P hat there. Is. And I'm going to write the formula down for you just because it's not on this page, but you are not required to do this when you actually do this in your practice problems. P times 1 minus P over N. Okay, so let's fill in those values. Our true proportion is 70. One minus 0.70 would be 0.30. And what was our sample size? It's in the problem. I'm not going to tell you. Great. 1,012. Okay, do you guys know how to get the fraction in on your calculator? Because I think this is easier if you just do it as a fraction. So you hit blue button, root button. And I'll give you a second to get where I'm at. Blue button, root button. Okay, to get the fraction, you hit green button and y equals. Then you choose the first option. So you can just do it as a divide if you like, but I personally like it to look like a fraction. So that was green button, y equals. Then I type in 0.7 times 0.3. Down in the bottom, I do 10, 12. And I'm going to be extra and do 4 decimal places. So I'm going to say 0.0144. Did you guys get the same thing as me? Yes? Okay. This only works if we have sampled 10% of the population. So I'm going to rewrite that condition. So what it normally looks like is this. 1/10 n. Which is not my favorite way of looking at it. So instead, what I like to ask myself is, take 10 times n. Is that less than or equal to how many people are in the population? So instead of trying to figure out what is 1/10 of the population, I just multiplied both sides by 10 so I could think about it like this instead. So 10 times our population size, or sorry, our sample size. I think that kid just ran away. It's 10,120. Do you think that there are more than 10,000 U.S. adults? Yeah, there's way more. There's like millions of U.S. adults. So this is definitely less than or equal to the population. So this all is based off of, is your sample size less than or equal to 1/10 of the population? I think it's easier to ask, is my population bigger than 10,000? Definitely. There's millions of U.S. adults. So your 10% condition is satisfied. So up here you say, because there are more than 10120 U.S. adults. So 1/10 n is less than or equal to big N. This gets easier as you do more, I promise, and faster. Once you do a couple of these, this gets much faster. So the center of our distribution is at 0.70 because we took a random sample. The spread of our distribution is 0.0144 because our sample is less than or equal to 1/10 of the population. I think I wrote that backward. Did you guys notice that? This is N, 1/10 big N. Sorry about that. And now it wants us to see if the sampling distribution is normal. So that's large counts, and I'll write that down for you because we don't have it on this page. You don't have to write it down on all of your problems. I'm just writing it so you have it right there. So I usually label it large counts. And then I'm going to do 10, 12 times 0.70. 10, 12 times 0.7, 708.4. That's definitely greater than or equal to 10, so that one's good. Then you do 10, 12 times 1 minus p, so that's 0.30. It's 303.6. That's greater than or equal to 10. So our large counts is satisfied, which means that P is approximately normal. So is the sampling distribution normal? Yes. Comma, P hat is approximately normal. So then the last problem is why we care. The last problem is why we even found all this information. Of the poll respondents, 67% said that they drink cereal milk. So these are the results of our poll. Of the poll respondents, 67% said that they drink the milk. Find the probability of getting this sample value. Find the probability of getting this sample value. Okay, well, we can now use a normal curve. So we're going to say P hat, squiggly, capital N on the word norm. That stands for normal. Comma. 0.70, that's not a comma, parenthesis. 0.70, comma, 0.010144. We are using a normal distribution with a center of 0.70 and a standard deviation of 0.0144. Why? So that we can calculate a probability. So we are finding the probability of getting a sample less than or equal to 0.67. Well, this is the same as the probability of some z value. So let's find that z value. We take our sample, so 0.67, subtract our mean of 0.70, and we divide by our standard deviation of 0.0144. We plug that into our calculator. I'm getting a z of negative 2.08. Can anybody verify that for me? Thank you. Now I need my darn purple table. So I go to my purple table. I go to my negative side. And I find negative 208. So I'm going to give you a second because I actually hear you guys getting that out and it makes my heart happy. Okay, I'm getting 0.0188. Great. If you want to know what percent that is, you can times it by 100, and that's 1.88%. Now, when you do these problems, family, I have written this so that this is all the work you need to show. That's it. You don't have to draw the normal curve unless it specifically asks you. You just need to state that your distribution is normal and find the z with the probability. You know what I'm saying? Do not stray from this form. Okay, what's our last question? Does this poll give convincing evidence against the claim? Explain. Way back at the very beginning of this class, I gave you the number that is the cutoff when deciding if a percent is too low. Anybody remember? 5%. So if you get a probability less than 5%, it's evidence against the claim. You would get a sample size this low or lower, not a sample size, sorry. You would get a proportion this low or lower only 1.8% of the time. So this is convincing evidence. So does this poll? Yes. This poll gives convincing evidence against the claim. What was the claim? That 70% of U.S. adults drink their cereal milk. This sample tells us that might not be true. We're not saying 100% for sure that that value is wrong. We're saying that this sample gives us evidence that it's wrong. And then the shortest way of summarizing this is, it is not plausible to get a p-hat of 0.64 if p truly equals 0.70. And that goes back to what we talked about at the beginning of class. It is such a low chance that you would get that sample that it has to make you really question whether that claim is true. You're hanging in? Okay, so in this lesson, the rest of this lesson is just, I think it's 2 more practice problems. So what I want you guys to do on Friday, we'll do, instead of learning a new lesson, we'll finish this lesson, and then you guys will just do, can you do 53? So no new lesson, we're just gonna finish this guy. We're good on that? Do we feel okay about that? Okay, and you're gonna email me or something if you have questions, right? Okay. I'm just gonna go visit Carter in the drive-thru though, this week.